Thank you for attending this webinar. I'm Marco Brambilla. I'm a technical advisor of WebRatio, and I'm also a professor at Polytechnic of Milan. I am one of the organizers and the inventors of the IFML standard and also of the WebML notation. Let's start with a general introduction regarding IFML. IFML, as you may know, stands for Interaction Flow Modeling Language, and it's now a standard from OMG. So let's start from a motivating question. The question is, I suppose you all have some kind of experience in designing and implementing user interactions and user interfaces of software applications. So the question is the following. If you think about when was it the last time you developed a front-end application and when you were really in trouble or you got mad about designing a front end of any kind of software application, probably you will end up deciding that user interface development is something that makes you mad. It's something that makes you mad because every time there's something to do and you need to do it down to the details, down to the bits and the pixels, you have some troubles. So this is a reassuring message. The thing is, developing front end of software is actually one of the most painful phases in software development, not just for you, but for everybody. So this is the reason why we decided that frustration should not be allowed to software developers for user interfaces. In particular, this kind of frustration comes from several motivations, several reasons. First is that complexity of user interfaces is definitely increasing in time. We were all used to crappy and basic user interfaces of websites 10 years ago. They have been increasingly improved over the years, and now we have impressive user interfaces in some software applications, both on the web, on desktop applications, and also on mobile devices. On the other side, frustration can also come from the really bad tools that exist at the moment for specifying and implementing user interfaces. As you know, we have some of them around, but most of them allow you either to design through drag and dropping widgets and the UI components, or some of them simply let you design and implement user interface by manually programming the interface itself. And this is also nothing really old, in the sense that modern interfaces, especially the ones that you design and implement through JavaScript, are often developed manually, completely manually, which is really painful. So just a few examples exist that allow model-driven approaches to user interaction design. And among these approaches, we obviously mention WebML and WebRatio in the web domain. Now, the point is, according to this, we see reasons for frustration in the availability of tools, reason of frustration because of the complexity of a problem, but we also see some frustration due to the fact that we don't have, at the moment, standard and shared modeling languages for designing user interfaces. So if you think about all the modeling standards, all the design standards that exist, starting from UML and all the surrounding world of modeling languages, it's really, impressive that there is a so big gap in the standardization for what regards user interaction modeling. So this gap is actually due to, probably, to some people tentatively using general purpose languages for designing user interfaces, and also due to the fact that for this kind of design, there are no solid implementations that let you go from the design level down to the implementation in general way. So that's the reason why we went we came to the decision of proposing a new standard for user interaction design. In particular, we thought about IFML, the interaction flow modeling language that I'm going to present today. The language is actually really inspired from WebML. You can learn about it on webml.org or webratio.com, which was the first and say implementer of the WebML notation since 2000, actually 2001. So what we aim at here is to move our experience and both at the theoretical and academic level and at the industrial level and implementation level from the web domain to the general purpose and general purpose world of front-end modeling of any kind of software application. So we started with this WebML modeling proposition, and we decided to go with OMG as a standardization organization. And especially we went there and made them an offer they couldn't refuse. So here is myself presenting the proposal together with an associate of mine that allowed convincing people there to decide that IFML was actually something they couldn't refuse. Okay, joke apart, the proposal went really well in the sense that in less than 2 years, we got the standard implemented and approved, which is definitely a record in terms of OMG time frame, because usually standards take much longer for getting approved. So the objective of IFML is basically allowing to specify the content of user interfaces, meaning what I want to put into a screen of my software application so that the user can see it, and also describing the navigation paths between the user interface elements and the events that happen in the user interface and that basically triggered by user interactions and user actions that allow navigation from an element of the interface to the other. The other thing is connection to the business logic, so to the backend side, and the persistence layers in terms of databases, files, whatever, for recording and retrieving information. So these are the purposes of the language, which are kind of aligned with the WebML ones, but now extend to any kind of software solution. And basically, by proposing a standard, we allow our users to move from a, say, proprietary notation or a set of proprietary notation to a set of artifacts that are officially available from a standardization organization like OMG, that are shared for every kind of designer that wants to apply them, and basically consist of these elements. First, it allows for specifying the perspective of the front end of the applications, keeping away the implementation issues of user interface development, and also keeping separate the backend design from the front end. This allows better communication with the stakeholders, not necessarily technical, and also opens the path to automatic code generation for the front end part, which was something missing in the modeling domain, except for a very few number of tools like WebRatio that provided it in some specific domains. So the focus of FML is obviously not the design of interfaces in terms of graphical appearance. So we forget about graphical rendering, icons, symbols, and fonts, and any kind of graphical properties at the moment. And we focus on what we call interaction. So it's not just graphical interface, it's interactions in terms of actions that user perform and events they trigger. What we can see in the application design is aligned with what we will get in the final outcome of the modeling, and we'll see it later. So it will allow people to specify events, multiple devices, components of the interface, the flow and the context of the user in terms of position, history of navigation, and so on. And we also provide modularization and validation features. In practice, the language is organized as follows. What you see here are the very basic, let's say, symbols of IFML. In particular, what you see now is a set of basic icons that are the most used in the notation. The first one is what we call container. It represents any kind of graphical container that can be used in a user interface design. Especially if you think about the web, a container could be a web page. If you think about a desktop application, a container could be a window, or for a mobile application, the container could be the screen of the mobile application. But the same could apply at the smaller scale, for instance, because containers could be used for defining panes, panels, or pop-up windows, any kind of interface container. So the purpose of containers is basically defining the borders of the user interface, while the content of the user interface is specified through view components. View components are basically the atomic publishing elements of the interface. What you specify with a component is what you can see in the page or in the window or in the screen in terms of published data, forms, or any kind of elements that appears in the interface of the user. The other crucial element of the language is the concept of event. An event is a happening that occurs based on something that triggers it either on the client side, meaning the client machine or the user that performs some event on the interface, or on the server side, because also system events are supported. Finally, the fourth core element is the concept of action, where an action is nothing more than a hook to some backend business logic that implements some capabilities, software capabilities of your system. So with these four very simple concepts, you can already start designing your IFML applications. These concepts are connected together with what we call flow. A flow is basically an arrow that connects a component or a container to another component or to another container. These flows can be of two types, and you see here their notations: what we call navigation flow and what we call data flow. Navigation flow is the possibility, describing the possibility for a user of navigating from one element to the other, from one page to the other, from one container to the other. So a navigation flow implies user interaction and triggers some change in the user interface when it's followed. A data flow, on the other side, is just a flow that describes transferring of data or information from one element to the other of the model. This is not bound to activity of the user. This is something that happens based on availability of the data and of the navigation of the user that is described by the navigation flow. In particular, this transferring of information is performed through parameters. Parameters are elements in the navigation that let you transfer data from one point to the other in the model, and this transferring is specified through a notation like this, a parallelogram symbol, that contains the mapping between the source and the target of a parameter. These elements are called parameter bindings. So for instance, here we have a parameter binding from a title to an album title element. And when more than that happen, we call it parameter binding groups. So just before showing the first example of IFML, I want to clarify a couple of points, especially for the ones of you that are used to designing and modeling with WebML. This small summary screen lets you see what is new in IFML with respect to, for instance, WebML and other modeling proposals similar to WebML, and also what is missing with respect to those proposals. In particular, what we have here as a very new concept is having the concept of event as a first-class citizen in the modeling. This means that while so far we assumed that events were something implicit that triggered execution, now events are, as you have seen, are explicitly shown in the models and are fundamental for triggering the navigation of the user. Okay? The other aspect that we have in addition in IFML is the fact that we can draw, for instance, navigation flows or data flows also from components to containers or from containers to components with no distinction on the kind of element. And we'll see why this could be interesting in general. We also have a missing aspect actually in IFML with respect, for instance, to WebML. What we miss here is the possibility of modeling orchestrations of, let's say, chains of operations or sequences of operations. This means that in IFML, you cannot design chains of or steps of backend executions of operations anymore. You can only design one single connection to the backend at a time. And we'll see some examples, and I will explain you later why this decision was taken. With respect to WebML, we also have some kind of change in terminology, and you see here the corresponding names. Anyway, we'll put these slides online later, so we will be able to get this list at your will. I don't want now to go through them, but the basic concept here is that we replace the concept of unit with the concept of component, and also some names that are quite familiar with WebML developers like data unit, index unit, entry unit will change their name to details, list, and form respectively. Links will become flows, and so on. Now, this being said, let's go to some examples that I think are more explicit than just talking. So let's assume the very basic example that was actually the first very basic example that we had also for WebML 10 years ago, where we want to model a screen or a page or a window with a list of elements here on to your left hand side, and the detailed description of one element once the user clicks on this element. How can I model this? I can do that through basic navigation described in this diagram. As you see here, we have a container, the artist container, that is the, let's say, the frame for the entire navigation, because we assume the whole navigation happening in the same screen. And then we have two components, the artist list and the artist component. These components are connected through a navigation link. The navigation link starts from an event element and ends into the other component. The purpose of this navigation link is to allow the user to do something on this container, on this component, and actually this something will be clicking on one element in the list of artists. When this specific event happens, this flow is triggered. When the flow is triggered, this modifies the state of the subsequent view component, so that the artist is updated according to the data that is passed through the flow, and this data is specified in this parameter binding group. Basically, what I'm saying here is that the selected artist that comes out of the click of the user from in the list ends up into an artist parameter in the artist target. This is another example, slightly more complicated, where we have not only one navigation but several navigations from the same component. In particular, the other thing we see here is the fact that we allow containers to contain other containers. So say the topmost container called albums and artists contains two subcontainers, one called again albums and artists, one album or artist. As you see here, you can tag containers with some annotations. XOR means that the two elements within these containers are in mutual exclusion during visualization. And there are other annotations. For instance, you can define a window to be modal, to be modeless, and so on. The other thing you see here is that you can have several events in the same component, and each event can trigger one or more navigations. In this example, the first one is exactly the same as before. Since this list here is a list that contains both artists and the list of albums of each artist, basically the idea is that if you click on an artist, you follow this path and you see the details. If you click on an album, you follow this path and you see the details. We'll see later that there's still something missing in this model, but I don't want to add all the details now. So here we have seen that we can have several events. We can transfer data over navigation flows, and we can change the state of the interface by updating the state of the components and also the state of the containers, because in this case, if you click here, you will see only the artist, because this is XOR container. If you click here, you'll see only the album, because this is XOR container. The other basic example we look at is the example of usage of actions. Actions, as I said, are references to backend behaviors. So for instance, if I have, in this example here, we have two containers, that could be two windows or two pages. The first one lists a set of albums. By clicking on one album, I trigger the deletion, so the removal of that album from my database. This is done through the action element in the model. once the action is completed, it will generate an event, supposing a confirmation of the or success signal regarding the action that will allow following the subsequent navigation flow down to the target page or window. Now, two simple annotations here. First, what is an action? An action is not the design or implementation of a behavior. An action is just a reference to some kind of behaviors specified somewhere else. So, in a sense, this can be seen, for instance, as a method invocation in object orientation, for instance, or as an invocation of an orchestration of web services. Suppose you have a description of an orchestration written in BPEL of web service invocations. You can invoke them here, or you have a sequence diagram describing some behavior, some interactions between classes. You can reference the sequence diagram here. What you cannot do is describe a complex set of operations in the IFML model. Any complex behavior that is more than one reference to a backend behavior cannot be modeled in IFML. So if you want to decode this for WebML users, basically, you cannot design operation chains anymore. The model doesn't allow to concatenate one action with another action before going to a page or to a container or to a component. You cannot do that. Now, probably some of you will are actually crying on your desk at the moment, but let me explain the reason for this. The reason is basically that actually this came out of some discussions we had over the years with some colleagues of ours, but also came out from a specific request from OMG. The request is the following. We want to keep IFML completely orthogonal with respect to the business logic and to the organization of the behavior of the backend. So if you start putting here sequences of operations or conditional decisions over which branch to follow during specification of operation chains, basically what you are doing is you are merging user interaction specifications with basically with business logic specification. So this was not acceptable in a standard targeted to user interaction specifically. Okay, so now going a little bit more into details, IFML lets you decide the level of details you want to use for your modeling. In particular, you may decide to stick to just containers and components, or you can go deeper in the design and, for instance, for each component, like in this case, you can specify more with more precision, with more details, the behavior, its behavior. What you see here is a component that has been detailed better in terms of description of his capability. First, besides the name of the component, we have also added something that is written here with these Guillemette symbols. That is what we could call the type of the component. Here we are not just saying that this is a message writer, with a typo actually, but it's actually, because this is just a name, but it's of a specific type, which is a list. And this is already something that brings a lot of some additional semantics, because so far we've been talking at the level that was like talking in WebML, at the level where we talk about units without saying which units we are using. Here we are talking about specific kind of components, a list, details, a form, and so on. The other thing you see here is that components can include internal properties that are called, let's say, or internal sub-elements that are called view component parts. View component parts are, again, sub-elements of view components that describe better their behavior. Some examples here: a list of parameters for the view component. I can specify them here. Another example that is very important, especially if you implement software that is largely based on data, is the so-called data binding. So data binding is basically the possibility of connecting a component to some piece of data model, content model, or persistence model. So in the data binding, you specify the concept you want to connect. In this example here, we are connecting to a mail message, and possibly the conditional expressions over this concept. In WebML parlance, this is basically the concept of master entity and selector. Because here I'm saying that this list of messages is showing a list of mail messages, where the condition to showing for showing the mail messages is that the mail message must be into a specific association between message group and the current message in the mailbox. So all this information can be added as a more detailed specification with respect to the core basic components. So in terms of components, we will have typically additional kinds of components like list of elements with data binding, forms, where the view component parts are not data bindings anymore, but are, for instance, fields, details that describe one element at a time in a persistence collection, and so on. The same way, I can also specify better the kind of events I want to connect to. For instance, the standard specifies two basic events, what we call selection event, represented by this checkbox in the event symbol, that describes the fact that the user can select one element in the component, or submit event, representing the fact that the user is submitting some information, for instance, through a form. The good news is that we are not bound to this set of events or components, because depending on your field or depending on your sector or kind of domain, you can add as many new element types as you want. This is because IFML is defined through what we call a meta model. Now, we don't have time at the moment to go through the complete theory of model-driven engineering and whatever. I'll spend just a couple of minutes on this. The general idea is, when you have a modeling language, you need to specify this language. So for designing this language, you have various options. You can define its grammar, you can define it according to various annotations. In OMG and in model-driven engineering in general, languages are specified through a meta model, meaning a model that describes the model. So a model that describes the language. For instance, this piece, it's a very small part of the IFML metamodel describes the fact that we have, for instance, interaction flow elements, that we have parameters in the language, that interaction flow elements can be, and this is a generalization hierarchy, can be view element or view component parts or actions or events and so on. And for instance, the view component that we have seen so far is just down here. It's a sub-element of the view element class that is a sub-element of the interaction flow element class. And the container is also here. So basically, in this way, I define how the language is specified, the concepts and their properties. So for instance, for a container, I know that there is a XOR property of type Boolean. Now, thanks to this way of designing the language, what we can do is the following. I can define first the language in a very abstract and resilient way. Second, use a modularization approach in the design of the language. And third, allow the language to be generalized. In particular, in the IFML, we actually have, even in the standard document, in the standardization official document, we actually have two main packages in the definition of the language. The first package is called IFML core. The core package describes the basic elements like these ones of flow elements, ports, flows, parameters, and so on, while in the core we don't include, for instance, the description of the specific kind of elements we have. The specific kinds of elements, such as the lists, the forms, and so on, the fields, are defined in what we call IFML extension. The IFML extension package includes, for instance, the concepts that are shown here in gray in gray boxes. In particular, here you see that in the core part is the topmost part here, includes containers, components, and component parts, which is very generic. In the extension part, we go into more concrete practice and we specify which kind of containers, components, or parts we're talking about. In particular, we decide that containers could be windows in a software application, or components can be lists, details, or forms. And component parts can be fields for a form, for instance. There are others, obviously. Now, this approach is open for extensibility because if you want, you can come in and change the IFML meta model by adding new packages of extensions. And so, if you want, you can invent your own extension for the web field, or for the mobile field, or for any kind of other domains, both vertical or horizontal. I mean, you can even think about, if you want, I'm not sure it makes much sense, but you can think about components specific for video games, or specific for banking applications, or specific for social networks, and so on. This way of working lets you have a language that can be tailored to your needs. But at the same time, these extensions must be coherent with the core part of the language and can extend these elements in the core part, or even this element in the existing extension in the specification. So for instance, say you come up with a more precise definition of list because you think about a hierarchical list of multiple kind of objects. Okay, this can be an extension of the list existing element. So at the end, you may end up with very complex models like this one. But the nice thing is that all of this is regarding the user interaction model. This, okay, it's a zoom in the previous example because that was a little bit too big. What you see here again is a main container containing a list of messages, a submission here, because this could be seen as a form where I can select several messages. A submission of this list leads to changing the state of the toolbar in the mailbox example, and then you can delete elements, archive, report some errors in the elements, move, and so on elements. And all of this is triggered by events. Also, at the event level, you can decide to refine the kind of event. Here we have just used the submit, but suppose you want to build the mobile version of the application, or your application for your iPad or something. You can decide and define new kind of events like the pitch, the pan, the zoom, any kind of or the twist, and so on. Any kind of event can be added, and so that you can say that, for instance, from the same component or container, different kind of events can trigger different actions or different changes in the user interface. Another interesting thing that is allowed in IFML is the possibility of having what we could call intra-component events and flows. So in the sense that you can define events also on components, and the behavior of these events could be a flow that leads back to the same component, or even to some subcomponent, which means view component part element. So for instance, this is a form with a set of fields, like this is done for writing an email message, for instance. Field for the target, carbon copy, hidden carbon copy, subject, blah, blah, blah. Actually, the thing is that, for instance, if you click on the general component for adding one attachment, what you get is you fill in some data in this form. If you click on forward, you change the state of the component to replay or forward, and this may change some visibility of the sub-elements of the component, and so on. So the general idea is you can define flows that go around all over the model at any element, at any detailed level you want. The other thing I want to show you here is that besides parameter binding, we also have another kind of annotation that is called activation expression. Activation expression is a condition that is applied to an event, and basically is saying that the event is triggered, let's say the flow is triggered, if the event happens and the conditional expression that I'm writing here is true. Okay, so this is something more I can add to the models. Oh, sorry, one last thing I was forgetting here. The other thing I can do is I can use event for capturing events and doing some and following the flow, but I can also produce events that will be catched by other components in the model. For instance, sending a message can produce a notification event that will be used somewhere else, for instance, for making some message appear in the screen. Okay. Now, we don't have time for going through the entire specification of the language, but basically you have several other aspects that are supported in IFML. In particular, you can define reusable modules and then reuse them anywhere. You can also define personalized and context-aware applications, for instance, considering the size or the kind of device, the position of the user, and so on, because there are some specific modeling concepts like called, for instance, viewpoint, that define the way, say, different views that the user can have over the application, and also context variables that define the state of the user or the device and so on. Okay, so in practice, what do you get from having a standard? Well, you get a lot of advantages. First of all, technical advantages that are, besides knowing that the language exists, you have an official and formal metamodel that describe the language. You also have an official and formal definition of the syntax of the language. So in the specification document, you find how the symbols must be specified in the models, and all the users of the models need to comply with these symbols. And you also get some more technical advantages that are, first, besides the new language, you also get a UML profile for this language. This means that you can do the same things within a UML editor by defining a UML profile for IFML. At the same and on the same line, you also get an official standard interchange format between tools. This means that if we'll have several tools allowing to specify IFML models, there is an official XMI exchange format that lets you draw some models in a tool and move them to another tool. For instance, this is the notation of the UML profile. The profile is obviously less convenient and less precise than the language itself. But the good thing is that if you want, you have perfect correspondence between the full language and the UML profile. Here we are using components, UML components, for showing behaviors. Sorry, the static aspect, and we are using sort of collaborations for describing how navigation and messages flow between an element and the other. So the big picture you get is that thanks to this exchange format, you can model your IFML diagrams in a tool like WebRatio, which gives you obviously very strong modeling and debugging and code generation features, also leveraging over our 10 years experience on this. But then you may also want to sometimes, I don't know, for some reason, to integrate with some standard UML tools, where basically you don't have domain-specific symbols or notation, but simply by having implemented the UML profile of IFML, you can import or export these elements through tools, also in terms of other domain-specific tools. So, and this is extremely important because you are not bound in any way to your vendors, to the tool vendors. And secondly, this is an enabler for broader modeling perspective over the software, because basically now, while you have completely integrated modeling of user interaction and other aspects of your enterprise systems, because IFML is entirely and completely within the MDA vision. So it's completely integrated with UML, it's integrated with BPMN, and with any kind, for instance, of extensions or profile of a UML, like SysML for system modeling, SOAML for web service modeling and design. And this is extremely valuable, especially for large organization, because you move from a siloed approach where every say perspective is modeled independently to a comprehensive modeling approach where you really get the entire design of your software altogether. Just to make an example, to give you an example, the connection to UML is very clear. If you want, in IFML, you can connect through data binding components to element in class diagrams, because data binding allows you to design a user interface where the components connect to a class, for instance, or an attribute. Same way with the actions. You can connect to the backend business logic that could be defined as a method in a class in UML, or even as an entire UML diagram, like a sequence diagram or activity diagram and so on, which is very, very convenient. And I'll spend another word at the end. So that's it in terms of the theoretical side. If you want to know more about the model-driven software engineering part, you can also refer to this book that we recently published and gives you a general hint on the big picture. And now, before closing, I want to spend a few minutes on the tooling part. As WebRatio, we really believe that IFML will bring great values to developers. So what we are doing now is spending a lot of effort in two directions. First one is implementing an open source editor for IFML that lets you design IFML models according to the standard notation. What you see here, this one you see here, is the editor, the open source editor that is actually already available for download in beta version from the WebRatio website. So you can go into WebRatio product IFML and you can download this tool. It's an Eclipse plugin. You can download it and use it. And as you see, you get all the IFML modeling features. You have actions, you have components, you have events with the basic event types. Event types that IFML provides, and connections in terms of flow of navigation flows and data flows, parameter binding, component parts. For instance, this is a form. Maybe let me zoom a little bit. Maybe this is better. This is a form with a few fields: address, email, map, photo, submission button. When you submit the button, you get the invocation to the update of the store. When the update is finished, you go back here, and so on. So, for instance, here now, what I'm showing is a very simple application called Acme that you can find also in WebRatio as an example. The other effort, why am I showing this? Because the other effort WebRatio is undertaking is moving WebRatio to the full compliance of IFML. As you see here, we have a first preview of a version of WebRatio where we move from WebML to IFML. The change is not that big. If you have a basic knowledge of WebML, it won't be hard to understand what's happening here. This is again the Acme example. What you see is how one could get IFML models in WebRatio. Obviously, the notation is slightly more appealing and more professional than the open source version. And the other thing is here you get entire code generation, debugging, and all the features for professional development you know about in WebRatio already. But as you see, the move is towards containers, components, component parts, the white elements inside, data flows and interaction flows, and parameter bindings specified with the parallelogram symbol. But in a sense, you can get exactly the same behavior that you design in the official IFML editor, also in WebRatio, with more, let's say, more appealing rendering and also more clearer representation of the specific elements, so that, for instance, the form annotation, we put it here like this, appears in WebRatio as a form icon here. And this is perfectly legal, also according to UML. Okay, so I think more or less that's it for today. We are actually perfectly on time with my speech. So I think from my side, I would conclude here. So thank you for attending you all.